क्या आपने कभी आसमान की तरफ देखकर सोचा है कि हमारा इतना विशाल सोलर सिस्टम असल में कैसे काम करता है? It is a massive 4.6 billion year old cosmic neighborhood. Today, we are going to condense all of that vastness into a fully functional, motorized tabletop model. By the end of this build, you will have an illuminated, rotating presentation piece ready to stand out in a darkened exhibition hall. To get there, you need an MDF board, foam balls, acrylic paints, and some basic electronics. Because we will install a geared DC motor, LEDs, and current limiting resistors, make sure you have an adult helping with the wiring. This project bridges the gap between passive observation and active engineering, turning abstract space facts into a tangible, working machine. This diagram shows a 60 by 60 centimeter base. Mapping accurate radii means Neptune's 35 centimeter orbit breaks past the board's edges. Therefore, we expand the foundation to a 90 by 90 centimeter square. Now all 8 orbital paths fit neatly inside, leaving corner space for information panels. Dead center goes our sun, the largest thermocol ball, about 15 to 18 centimeters across. Hollow it out and securely mount an LED inside, remembering to wire in a resistor so the bulb operates safely without burning out. We illuminate this center point because our sun, a G-type main sequence star, is an incredibly active, dynamic body, marked by complex sunspots and magnetic storms. Wiring it as the glowing core of our project accurately visualizes its true physical dominance. It is the gravitational anchor, containing 99.8% of the entire solar system's mass. Next, we prep the inner rocky planets. Apply gray patches for Mercury, cream yellows for Venus, and rust-red coats for Mars. For Earth, capture its dynamic atmosphere. Paint a deep blue base and layer swirling white atmospheric cloud systems directly over the oceans and continents. Moving past Mars, we hit the outer giant planets. We categorize Jupiter and Saturn specifically as gas giants, while Uranus and Neptune are classified as ice giants. When painting Jupiter, focus heavily on recreating its distinct rust-colored horizontal atmospheric bands, and include its most famous feature, the Great Red Spot. Saturn requires a pale yellow base, but its defining feature is the ring system. Cut these from thin cardboard and mount them so they clearly separate from and cast a shadow over the planet's spherical body. Keep in mind, while our color and texture work here is scientifically grounded, the physical size ratio between these models is heavily exaggerated, so they remain clearly visible for educational purposes. Between the orbits of Mars and Jupiter, scatter and glue down small, irregular rocky fragments to represent the main asteroid belt. You will also build a dedicated side section for dwarf planets. This explains why Pluto is excluded from the main mechanism, reflecting the definitive 2006 decision by the International Astronomical Union to reclassify it. Now it's time for the mechanical assembly. Mount your slow-speed geared DC motor directly underneath the center of the board, routing the wires safely away from the rotating support platform. Wire these components into a unified control panel at the front edge. Connect the main battery through a single switch so that flipping it simultaneously powers the rotational motor and the sun's internal LED. This diagram illustrates a mechanical flaw. Because our planets share a single rigid platform, they travel at the exact same speed. Add a disclaimer explaining that in reality, planetary orbital speeds vary drastically, with inner planets racing quickly while outer giants crawl. Openly acknowledging this mechanical limitation proves to examiners that you have a mature, comprehensive understanding of astrophysics beyond just gluing parts together. When exhibition day arrives, you will be in a loud, chaotic environment, competing for attention against dozens of other displays. Your advantage comes the moment the teacher approaches. You dim the surrounding lights, hit your master switch, and let the glowing sun and synchronized mechanical orbits immediately draw them in. Keep your presentation tight and confident. Start by stating, Hamada solar system लगभग 4.6 billion years purana hai. Our sun is got gravitational center hai. Then walk them through the 2 main categories, the rocky terrestrial inner planets and the outer gas and ice giants. Be ready for quick follow-up questions. If they ask for the extremes, smoothly identify Jupiter as the largest, Mercury as the smallest, and Venus as the hottest due to its thick atmosphere.
Delivering this precise data while operating the control panel proves you have mastered the physics and scale behind the model. ऐसे छोटे एजुकेशनल मॉडल्स बनाकर ही हम इस अनंत ब्रह्मांड के रहस्यों को करीब से समझ सकते हैं।